Welcome. Today let's try to solve Leetcode problem 765, couples holding hands. So we are given a row. So these rows are just numbers. So for example, if the number which is 0 and 1, it means it is a couple. 2 and 3, it is just another couple. Yeah, so this is according to the description. For example, 2 and 3, another couple, 0 and 1, it's one couple. 2n minus 2, 2n minus 1, it is still a couple. Yeah, so I'm gonna use this example 0, 2, 1, and 3 to explain how can we solve this problem by using unified. Now let me make a drawing of what it looks like while we are solving this problem. So for example, I forget the numbers. For example, it is just let me check what it is. 0, 2, 1, 3. 0, 2, 1, 3. Yeah, if we have an array like this, we are sure 0 and 1 is a couple, 2 and 3 is another couple. So how many swap do we need? It is just one swap because this 2 can swap with this 1, or this 0 can swap this 3, but it is still one swap. But how can we solve this problem? Yeah, so we can use the numbers given by the description to transform the numbers as a couple. So for example, 0 and 1 should be one couple. 2 and 3 must be another couple. Yeah. So we can use this 0 and 1 divided by 2 to check the result. Yeah. If 0 divided by 2, it is 0. 1 divided by 2, it is still 0. Yeah. So for 2 divided by 2, it is 1. 3 divided by 2, it is still 1. So it means 2 and 3 is a couple. 0 and 1 are another couple. Yeah. Because this is equal to 0 and this is equal to 1. Yeah. Now we are going to solve it. Let me start. Yeah. Yeah. Now we are going to prepare the array just as couples. But how can we prepare this array as a couple? We can check one by one. So for example, we can check this 0 with this 2. So if 0 divided by 2, it is 0. And 2 divided by 2, it is 1. If they are not equal. So this means 0 and 2 must not be a couple. So what we need to do, we need to change this swap 0 or swap 2. Yeah, but we are not sure which one we need to swap. Is this 2 swap with 3 or others maybe? Yeah, but we are sure this 0 and 2 must not be a couple. Yeah, so what we can do, because this 0 is represented by just a 0 node, this 2 divided by 2, it is node 1. Yeah, so the node 0, this is a couple. Yeah, as a couple 0, we can number it. This is a couple 1. Yeah, so we can connect couple 0 and couple 1. This means there must be a swap. Yeah, because this 0 and 2, 0 divided by 2, 0, 2 divided by 2, 1, because they are not equal. It means there must be a swap. Now we are going to check these two numbers. 1 divided by 2, it is 0. 3 but divided by 2, it is still 1. 1 not equal to 0. It means it must have a swap. Yeah, this 1 and 3 must have a swap. But what the swap looks like? It means still, it is still 0 and 1 need to have a swap. So this is the final result. 0 and 1 connected. How many swap do we need? And we just need to check how many nodes. So in total, there are 2 nodes. And there's only one connection. So n minus 1. It means 2 minus 1. So the result is just 1. Yeah. Let's try to use another example, maybe more clear. So now let's try to use another example. Maybe we can prepare an array of 1, 3, 2, 4, 5, and 0. Yeah, so for example, there are 3 couples, and yeah, if this one gonna be a couple, maybe this 3 can change with this 0. Yeah, if it changes with that 0, here will be 1, 0, and here will be 5 and 3. But currently we are not sure this is finished because this is a couple. Now 2 and 4 with 5 and 3, what are we gonna do? We can change this 4 with 3, so it will become 4, 3, 5, 2, 3, yeah, 5 and 4. So this is 3. So 2 and 3 becomes a couple, 5 and 4 becomes another couple. So now it is finished. Yeah. But exactly how should we solve it? So we're gonna still check that because this 1 divided by 2, it is a 0, means this is a 0 node. Because we're gonna always use a couple, use 2 people as 1 node. Yeah. And this is 3 divided by 2, it means node 1. So 0 and 1 should be connected. Now we are going to check this 2 and 4. 2 and 4, it is still 1 and 2. 1 and 2 should be connected. Now we're gonna connect 1 and 2. Now we're gonna check this one. This is 5 divided by 2, it is 2. 2 and 0 should be connected. Now as you can see it, 0, 1 and 2, it means 3 couples should be connected. 3 nodes actually, 3 nodes should be connected. Yeah. So this means how many swaps do we need? How many nodes? There are n nodes. And if they are connected, actually, if it is 3, actually this is 2 because they are always connected. Yeah. So we just need 2 swaps. So it means n minus 2 is the final result. Yeah. If it is just 0 and 1 connected, so it is n minus 1. Yeah, because this is 2, this is 0 and 1. 2 minus 1, it is 1. This is 3 minus 1, it is 2. So n minus 2, and this is n minus 1. Yeah, now let's go back to the code editor to finish the coding. So as I gonna use the unified to solve the problem, let me copy any kind of the unified template. Yeah, so this is what I prepared. I just prepared a rack and parent array and used the find, connected, and union. Yeah, some of them I will not be used, but I will keep the template like this. Now I'm going to prepare a union find. It would be UF. And yeah, let me first check the length of the rows. It's gonna be n, the length of the row. And inside the union find, it would be n divided by 2. Yeah, because we're gonna use how many couples to represent the node inside the union find. Yeah, we are always check if 2 couples can be connected or not. Now I'm going to check from 0 to n, and I have a step of 2. Yeah, because I'm going to check if they are a couple or not. So how can I check? I just need to use A and B, means there are 2 people inside a couple A and B. It is just row I divided by 2 and row I plus 1 and divided by 2. This just means 2 numbers. They are just neighboring numbers. We are just check if they are a couple or not. If they are a couple, we don't need to do anything. If they are not a couple, it means we need to connect the 2 nodes. Yeah. If A not equal to B, we're gonna use UF dot union with A and B. Finally, we just need to return how many steps. Yeah, here I'm gonna use a sum of uf dot parent I not equal to I for I in range n divided by 2. Yeah, we can also use this way to simplify the calculation. We don't need to use n minus if they are equal. We can directly use if they are not equal. Yeah, let me go back to explain why we can use like this. So here, while we are comparing with this one, so this is there are 6 people inside this array and 3 couples. So inside the couples, while we are doing this, what gonna be the final result inside the parent array? So the parent array, so for example, 0, 1, and 2 would be connected. So the parent array would be something like this: 1, 1, and 1. So this means for node 0, 1, and 2 should be connected. Yeah, but inside it is 1, 1, 1. But how should we calculate? So for this parent I here, for parent 0, it is 1. They are not equal, so we're gonna count by 1. Parent 1 equal to 1, they are equal, we're gonna not count. And for this one, parent 2 not equal to 1 because it is 1. Yeah, so we're gonna have another count. So how many? There are 2. So this is the final result. We're gonna return this 2. Yeah, because it is always dependent on the parent array. Because from the beginning, the parent array would be 0, 1, and 2. After connected 0, 1, and 2, the parent array will be 1, 1, 1. So it means there must be 2 nodes which are not equal, the parent I not equal to I. It is this one and this one. There are 2. Yeah. So this calculation is also the same. So for example, inside of the parent array, maybe inside of the parent array, it is 1, 1, 1, and 2, 2, 2. Yeah, let me make it, it cannot be like this. Let me just use a reasonable example. Maybe it is like this. So it is a 1, 1, 1. So here 0, 1, 2. Here will be 3. Yeah, 3, 3, and 3. Yes, just imagine there are 6 couples, and these 3 are connected because this is a parent array, and these 3 are also connected. So how we should check? So if the parent I not equal to I, how many in these areas? There are 2. And for this one, the parent I, here is the parent 3, not equal to I is 3. It is equal, we will not count, but these 2's are not equal, so 2 plus 2, it is 4. Yeah, so this means there are like 1, 2, 3, 0, 1, 2, 0, 1, and 2 are connected. 3, 4, 5 are also connected. Yeah, so these numbers are just means the couple 3, 4, and 5 connected. So it means there are only 2 swaps, and this 0 and 1, 2, there are also 2 swaps. Yeah, it's also the same. Now let me just run it to check if it works. As you can see, it works. Now let me submit it. Yeah, as you can see, it passed and it's pretty fast. Now let's analyze the time complexity. Yeah, because for the unified, normally for most of the time, we're gonna prepare path compression and racking. Normally this will be O1 just for find and union. And for here, we just check how many nodes in total. So the time complexity is just ON. Thank you for watching.